Okay, problem number 1C. So we're looking at the limit as n goes to infinity of the quantity 1 plus 3 over n raised to the nth power. Boy, this one looks like it's going to be fun. If I plug in infinity here, we end up with 1 plus 3 over n is just going to be 0. So we have 1 plus 0 raised to the 0. So we end up with 1 to the infinity, which is also an indeterminate form. Go figure. So what we're going to do is we're going to say limit is equal to L. So we have L is equal to the limit as n goes off to infinity of 1 plus 3 over n raised to the nth power. Now, since we have something raised to an exponent here, the first thing I'm going to do is I'm going to take the natural log of both sides here. So I'm going to say the natural log of L is equal to the natural log of all of this. So limit as n goes to infinity of the natural log of 1 plus 3 over n raised to the nth power. Now that I've got this in the natural log, this whole piece comes down in front, right? Because that's one of the properties of logarithms. So we have the natural log of L is equal to limit as n goes off to infinity of n times the ln of 1 plus 3 over n. Okay, let's make that a 3 over n there. Now, we still have an infinity times 0 here, so we could go over here and we'll say infinity times 0. Also a indeterminate form, so we've checked that, and I think, okay, well, we could use L'Hopital's on this, sort of, right? We still have to do some operations on this before we go ahead and do this. So what I'm going to do is I'm going to say, I'm going to multiply top bottom by 1 over n, because I want to get rid of this piece. I need to put this n on the bottom. So we're going to have the natural log of L is equal to the limit as n goes off to infinity. The 1 over n and the n cancels. So we have the natural log of 1 plus 3 over n, all divided by 1 over n. See, that's the same idea here. There's a couple of ways you could get this, but that's the way I chose. We top and bottom by 1 over n. We're going to go ahead and replace our n's with x's. So this is the natural log of 1 plus 3 over x divided by 1 over x. And we're going to take our limit as x goes to infinity. The reason you change it from n into x is it's kind of a thing you got to be really careful about. X's are continuous variables, n's are discrete variables. So it goes from 1, 2, 3, dot, dot, dot. And if we're going to take derivatives, you got to take derivatives of continuous variables. And it's one of those things that you just kind of have to, keep an eye on, because otherwise you get into trouble with it. Because there's a chance, there's a time and a place where it's going to backfire and it doesn't work. So what we're going to do is we're going to use L'Hopital's now. So now apply L'Hopital's. Okay, so we have the natural log of L is equal to, now I got to take the derivative of the top. So that's going to be 1 over 1 plus 3 over x. And now I need times the chain rule here, right? So the derivative of 1 is 0. We have, this is going to be negative 3 x to the negative 2 here. So we're doing the chain rule of what's inside of here. So x to the negative 1, right? We're going to get negative x to the negative 2. Okay, so that's our value there. Divided by, and then on the bottom, we end up with negative 1 over x squared, right? This is x to the negative 1. Take the derivative, we get negative 1x raised to the negative 2. Okay, so here we have, okay, it's a little bit longer than I wanted to be, but here we have the natural log of L, the natural log of our limit is equal to 1 over 1 plus 3 over x times negative 3 over x squared, all divided by negative 1 over x squared. Okay, so what I'm going to do here is I'm going to multiply top and bottom by x squared. All right, that's going to cancel out on the bottom. I'm going to go ahead and make an executive decision to say the negative sides are going to cancel. The x squareds on the top are going to cancel. So we pretty much end up with 1 over 1 plus 3 over x. And I think we have times 3 as we're sitting here, right? Because we have this 3 sitting here. The negative signs canceled. So we have natural log of L is equal to 3 over 1 plus 3 over x. And we, of course, we have the limit as x goes off to infinity. Clearly, this is not an indeterminate form, right? Because the limit as n goes off to infinity of 3 is 3. But on the bottom, we have 1 plus 3 over x. This is going to turn into a 0. So we have 3 over 1 plus 0. So let me go ahead and write this out like this. So we have natural log of L is equal to the natural log of 3 over 1 plus 0. I put that in quotes because I took my limit, and 3 over x, the limit for 3 over x is 0. So we pretty much end up with natural log. Oh, wait, no, we don't have a natural log here. It's just it was the limit. Okay, that's not natural log. So we're okay with this. So we have the natural log of L is equal to 3 over 1. So we're just going to say 3. Now we have got to unlogify the whole thing. So we're going to say e to both sides. So we have L is equal to e cubed. And that is my limit for this sequence. Okay, so that's what we converge to. It still converges. It settles on a particular value. And that's what we're going to do. So thank you very much for watching the video. When you're dealing with L'Hopital's, do me the favor, verify that it is indeterminate form before you go off and take L'Hopital's rule on things, okay? L'Hopital's rule is so powerful. Even if you mess up, it will frequently give you the right answers. So the only thing I have to really grade you on is, did you follow the steps, okay? The first step is you check to see whether or not it's an indeterminate form. Then we can go off and start dealing with L'Hopital's stuff, okay? Thank you very much for watching. I'll see you in the next video, and take care.